All right, so consider this example, a two-dimensional example, just x, y. All right, so you remember this is the vector field where, if you pick 1, 1, the vector field is also 1, 1, 1, 0, the vector field is 1, 0. Everything is pretty much going away from the origin, and that's your. Okay, so that is your vector field. Maybe I should put one more here. At 0, 0, the vector is 0, 0, right? And so, great. What can we do here? Well, look at the divergence. This will be, you see what the divergence is here? The divergence is going to be, this is P and this is Q. It's Px plus Qy, and that's 1 plus 1, and that's 2, okay? And so 2 means that at every single point, um, things are going away more than coming in, okay? And that's certainly true here, because for instance here, if you pick a point here, this is the point 2, 2. So the vector field here will be like this, right? And you can see more is going out than coming in. Sorry, I probably should not have overlapped here. This is supposed to be x, y, okay? So at every single point, more is going out than coming in. And in fact, the net difference, net outflow will be 2, okay? Curl of f, in this case, is what? Quicks minus pay. All right, and so if you think about this, this is P, this is Q. Well, that's, QX is 0, PY is 0, and so it's 0. Now, do you see why there's no curl here? Well, because nothing is rotating at any single point, okay? And so that is what basically, you know what, I should be more careful here. What I calculated is the last component. Remember, technically the curl, even though f is two-dimensional, we are considering this to be embedded in the three-dimensional space. So I should say officially, technically, the curl is still a three-dimensional vector, 0, 0, and then the last one is quicks minus pay. So instead of what I had before, I should say 0, 0, and then qx minus py. But it's still 0, 0, 0, or the 0 vector, because there is nothing spinning. Okay, there is no rotation about any point in this vector field, right? So that is a good way to think about this. All right, let me give you an example too. This is the vector field negative yx. All right, so what does it mean? Negative yx, this is the vector field that looks like this. Okay, so this is a point 1, 0, right? What's a vector? What's a vector at 1, 0? That would be 0, 1. That's this one. And how about here? This is the point 0, 1. So it'll be negative 1, 0. That looks like this. All right. If you remember, this is the vector that seems to rotate about this point. All right. So for instance, here's another point. This is the point 2, 2. And at this point, the vector field or the vector is negative 2, 2, negative 2, 2. Right. And so that would be this. And then you can see that it's going to have a big, counterclockwise whirlpool type of a vector field. All right, so here, let's study the divergence. Okay, so I'm thinking of this as negative y x 0, right? So if you take the, if you take the partial of negative y with respect to x, you get 0. The partial of this with respect to y is 0, and of course the last one is 0. The divergence happens to be 0, okay? And you can tell that if you pick any point, right, because things are just going around, right, the net outflow will actually be 0. The curl is different. The curl of ZF, remember this is going to be 0, 0, and then Q quicks minus pay. In this case, quicks is 1, and pay, PY, is negative 1. So this will be 0, 0, and then 1 minus negative 1. And that is 0, 0, 2. That is non-trivial, okay? And what that means is in three-dimensional, if you look at this from a three-dimensional perspective, let me use this example here again. What we are seeing is something like this, right? And so at any single point, let's pick the origin, okay? At this point origin, this curl is actually going like this, 0, 0, 2. Okay, and that's because this is the axis, so that if you put, remember, if you throw that the paddle, wheel right here, it's going to start, the axis will start going in this direction, because the everything seems to be rotating along this horizontal surface. Okay, and the axis about which the flow is most natural will be the z-axis, and so that's what you're seeing here. And two is the tendency of the object, the fluid or the gas or the energy to be going around this axis. Two is, and it's just a tendency. If it's 20, it's the tendency will be more. Okay, and then here's another example. This time I'm going to give you a three-dimensional example. I will give you two more. Z, 0, negative x. What in the world is this? Okay, let's picture this. This is, by the way, this one is y independent. There is no y in here. So I think maybe it's easier for you to describe this. Now, this is a point 0, 0, 1. This is a point 0, 0, 1. So the the vector at this point will be 1, 0, 0. That's going to look like this. Okay. Now here's a point. This point is 1, 0, 0. So it'll be 0, 0, negative 1. That will be this. And this is a point. Let's say this point is 0, 0, negative 1. And at that point, it'll be negative 1, 0, 0. That's this. Okay. And you can probably guess, what happens at this point. Negative 1, 0, 0. It'll be 0, 0, negative, no, 0, 0, 1 at this point. So it'll be this. So you can tell this is also going around, right? It's like, again, the whirlpool kind of motion along the y-axis, right? So look at what the divergence is. The divergence of f, which we can write as a dot product of the gradient operator, and f is you take the partial of this, PQR, partial of z with respect to x, that's 0. Partial of 0 with respect to with y is 0. The partial of negative x with respect to z is also 0. Okay, so at any given point, exactly the same amount is flowing in as flowing out. The net outflow at every single point is 0. The curl of f, which is the gradient operator cross f, again, this is not so simple, but you can do ijk, partial x, partial y, partial z, z, 0, negative x. Okay, and watch what happens here. When you do this minus this, that's just 0, right? Okay, let's go to the next one, which is basically a negative of this minus that. So I'm going to put minus, and then, that's negative 1, okay? And then minus the partial of z with respect to z, that's also 1, okay? And then the last one will be this minus that. So 0 with respect to x is 0, and then partial of z with respect to y is also 0. So what happens is this will be 0, 2, 0, okay? And so that vector at every single point, if you pick, for instance, the origin, it'll still be 0, 2, 0. So this is and not surprisingly, that's the axis about which the circular motion, the spinning motion is most prevalent, right? Because after all, this the fluid is kind of going around it this way, very much in about it's going around so that the axis of rotation is in the direction of the positive y-axis, and so that's what you're seeing here. All right, one more example, and I will stop. This vector field is negative x, negative y, negative z. What in the world does that look like? Okay, so in the three-dimensional space here at the origin, of course, it's 0. But if you pick any point like x, y, z is 1, 0, 0, this will be negative 1, 0, 0. Okay, at every single point, you can see it is pointing to the origin. Okay, if you pick a point like, let's say here's a point, maybe like 2, 2, 2 or something. Well, the vector is negative 2, negative 2, negative 2. That's going to go straight at this point, right? Pointing straight at the origin. So every point At every point, this vector field is going pointing straight at the origin. The farther you go, the bigger or the longer the vector is. All right, let's think about the divergence. The divergence is the partial of this with respect to x, the partial of this with respect plus the partial of y with negative y with respect to y, that's -1, plus the partial of z, sorry, the partial of negative z with respect to z, which is -1, that's -3, okay? So because more things are coming in, like at this point, it'll be like this coming in, more is coming in than going out, you can see this value is negative. And the curl of f, that would be I, J, K, partial x, partial y, partial z, negative x, negative y, negative z. And if you do this, you get, first it's this minus that, that's 0. And the next one will be minus of this minus that, okay? But again, that would be 0 minus 0. And then finally, the partial of negative y with respect to x minus the partial of negative x with respect to y, that's 0. So this will be the 0 vector. And again, the reason this is 0 is because the curl, there is nothing curling around. There is nothing spinning around in this vector space. Everything, vector field, everything is going straight toward the origin. The origin is like the black hole, meaning that origin is this one big sink where everything is seems to be flowing into. And so the divergence is negative. And in fact, divergence is negative at every single point, which is -3. But the curl is not there because nothing is rotating or turning or spinning. All right, so I hope these examples will make it clear. Okay, so this section has been pretty simple, and I think it's straightforward. I don't think you'll have any difficulties doing your homework rather than just finding curl and divergence of various vector fields. And so take a little break because the next 3 or so sections will be much longer and they could be intense. All right, so I hope this is a sort of a nice, easy section for you to enjoy in the middle of chapter 6. All right, do your homework and have a great week. Take care. Bye.